All right, here we're looking at function operations. And operations with functions is essentially the same thing as we dealt with when we were dealing with polynomials, adding, subtracting, multiplying, dividing, those kind of things. The only difference here is the notation that we use. For example, when I look at addition and subtraction, what this is saying, that this first piece right here, that's saying f plus g of x. And notice that's not times x, that x isn't being multiplied, I can't distribute it, it's f plus g of x. In other words, what it's saying is I'm taking the f function and the g function and I'm adding them together, and they're going to have x values in them. All right. If this was f plus g of 2, I would add the two functions together and then plug a 2 in. So just like function notation before with something like f of x, whatever's in the parentheses, that's what we're plugging in. And it's the same thing here for this last piece. Whatever's in these parentheses, that's what I'm plugging in for x, okay? And that's why that piece is listed. And the other way you might see this, you might also see it as just f plus g is another shorthand way that says, hey, we're going to add these two functions together. And typically when we're not plugging anything in, we'll see it written that way. Same thing with subtraction. You might just see f minus g. It's saying subtract the two functions and leave it in terms of x, okay? The reason that we have this other notation right here is because this has this piece right here that tells us what we're plugging in for x if need be, okay? So again, this notation is just telling us to add the two functions or subtract the two functions. For example, if I have f plus g of x, what it's telling me to do, it's telling me to take the f function, which is the x squared minus x plus 1, and the g function, which is the x plus 2, and essentially take those two functions and add them together. All right, that's all this is telling me to do. It's telling me to add these two functions together. So in order to add these two functions together, I just combine like terms. The x squared is kind of all by itself, so it doesn't have a like term. That's an x squared. The negative x and the plus x right here, those are like terms. They combine to give me a 0. And then the 1 and the 2 combine to give me a 3. And that's it. Okay, so when I add the two functions together, I get an x squared plus 3. And the same thing here. This time I have g minus f of x. I'm going to start with the g function. The g function is the x plus 2. The f function is the x squared minus x plus 1. And again, this is telling me to subtract this time, so I'm going to subtract these two functions, and that's it. All right. In order to subtract them, I'm going to change this to adding the opposite. And now I'm just going to combine like terms just like I did before. That's going to be a negative x squared. That's going to be a plus 2x. And that's going to be a plus 1. Okay? So it's just a different way to tell me to add two things together. And that's it. Same thing here. Very similar for multiplying and dividing. If I have f times g of x, I'm multiplying the two functions. If I have f divided by g of x, I'm dividing the two functions, and again, this of x, I'm not multiplying by that. That's telling me what to plug into this function. So if I had f times g of 2, well, then I'd know to multiply the two functions and then plug a 2 in. Okay? So again, that's just denoting what we plug in here. And just like before, typically we'll see this as just f times g when we're not plugging anything in, or we'll see this as f divided by g when we're not plugging anything in. So all of these notations, just shorthands telling me to either multiply or divide the two functions. For example, when I look at this guy, I want to do g times f of x, so I take the g function, which is the x plus 4, and I should write that just a little bit lower here, so I have some space to work, which is the x plus 4. And then times the f function, which is the x squared plus 3x minus 4. And because I'm multiplying, I just multiply. In order to multiply these two things, I distribute. I distribute the x. When I distribute that x, it gives me an x cubed plus 3x squared minus 4x. And now I distribute the next term. I distribute the 4. When I distribute the 4, that gives me a plus 4x squared, a plus 12x, and a minus 16. And now I combine like terms, leaves me with an x cubed plus 7x squared plus 8x minus 16. And that's it. Okay? So I'm just multiplying the two functions, and that's all there is to it. When I look at the next one, again, the order here is important because I'm doing f divided by g of x, so I have to do the f of x function, which is the x squared plus 3x minus 4, divided by the g of x function, which is the x plus 4. And now from here, in order to do this division, I could do long division, or with this one, I would probably do synthetic division. So synthetic division, I take the opposite of this guy right here and put it in my box. So I put the negative 4 in the box. I write down my coefficients, 1, 3, and negative 4. And now I bring this guy down, and I multiply, and I add straight down, and I multiply, and I add straight down. And now I have to interpret this answer. Because I started with an x squared and I divided by an x to the first, this interprets into a 1x minus 1. and that's what I get when I divide. There doesn't happen to be a remainder this time. If there was, I would put it over the thing I was dividing by. Okay, but since it's divided evenly, the other way you could approach this is I could have done it this way. I could have factored this numerator. This numerator factors into an x plus 4 and an x minus 1. And you'll notice right away that I have something in common with the numerator and denominator. I could actually cancel out those x plus 4s, reducing the fraction, and get an x minus 1. Okay? Because remember, division and factoring are technically the same thing. We've used division before in order to factor things. Well, here I could use factoring in order to divide by canceling those out. But either way, I get an x minus 1 when I divide these things. And that's it. The operation that we haven't seen before is the composition. Okay, the composition is a new operation, and the symbol for that operation is this little thing that looks kind of like an O or a 0, but it's smaller and it's kind of written in between, kind of where a plus sign or a minus sign or a multiplication sign would be written. And the couple mistakes that we make here, sometimes we mistake this for an O and think that I'm just writing fog all over the paper, which I'm not. Okay, this is f of g. It's the composition. The other mistake we make is we get it mixed up with multiplication. Just remember, multiplication is a solid dot. This is an open dot. Okay. And the composition is essentially telling us to substitute one function into the other function, okay? The way we read this, as we read left to right, this is f of g of x, okay, as I read this thing. F of g of x, okay? It's the composition. I'm plugging one function into another function, okay? And here's the nicer way to look at this thing, is to look at it this way, okay? Basically, I have the x plugged into the g, and then I have the g of x function, that entire function plugged into the inside of f. Okay, so think of it this way. If I look at something like this guy, for example, this would be f of g of x. Okay, basically, it's telling me to take this x value and plug it into the g function. Okay, and if I were to plug an x value into the g function, not a trick question, if I plugged an x in over here, it would leave me with an x minus 5. Okay, which is pretty obvious. It already has an x plugged in, so it stays the same. All right, but now what this is telling me, it's telling me to take this x minus 5 and plug that into the f function. And here's what that looks like. Because remember, with function notation, whatever's in the parentheses, that's what I plug in for x. So remember, the f function was x squared plus 3. If that was f of 2, I'd plug a 2 in and do 2 squared plus 3. If it was f of negative 10, I would do negative 10 squared plus 3. But since it's f of x minus 5, I plug in x minus 5 in here, and I do x minus 5 squared plus 3. Okay, so I'm essentially substituting in. I plugged the x into the g function and got x minus 5, and then plugged the x minus 5 into the f function and got x minus 5 squared plus x. All right, and now from here I'm just going to simplify this thing. Keep in mind that x minus 5 squared is actually x minus 5 times x minus 5, which is important because when I multiply that out, that's x squared minus 10x plus 25 plus 3. And now I combine like terms. That's x squared minus 10x plus 28. Okay? So again, I'm plugging one function into the other function. If I look at the next one, very similar, except I'm kind of doing this in reverse this time. This is like g of f of x. Again, if I plugged an x into the f function, it would give me an x squared plus 3. It wouldn't change the f function. But now I'm going to take that x squared plus 3 and plug it into the g function. The g function was x minus 5, but instead of x, I'm going to plug in the x squared plus 3. And now I combine like terms. That gives me an x squared minus 2. And that's it. Okay? It's just substitution. I take the x and I plug it into one function, and then I plug that value into the next function. All right? If I look at the next guy, this is essentially saying, okay, what would it do if I had f of g of 2 instead of f of g of x? Well, keep in mind that right here, here's f of g of x. Let me rewrite that. F of g of x is an x squared minus 10x plus 28. So f of g of 2, well, that's just saying instead of x, plug a 2 in. That would be 2 squared minus 10 times 2 plus 28. Okay? That's what this is essentially telling me to do. And when I do that, that leaves me with a 4 minus 20 plus 28. It looks like a 12. Okay? And the trick here is, if I were to do f of g of 2, this one's really easy because I already did f of g of x and I just had to plug the 2 in instead of the x. But if I didn't have this problem that was up here, if I didn't have f of g of x, I would either have to find f of g of x and then plug the 2 in, or you can think of it this way. If I do this one piece at a time, let me cover up that answer and so I can see up here. But basically, if I look inside these parentheses, this is telling me to take this 2 and plug it into the g function. So if you come up here and plug a 2 in for the g function, that would equal a negative 3, okay? And then it's telling me to take that negative 3 that I just got and plug it into the f function. So if I plug a negative 3 in over here, you can see right away I'm going to have 9 plus 3, which is a 12, which is exactly what I got down here. So you can kind of plug it in one step at a time, almost as a chain reaction of substitution. And that's the same thing we were doing when I did the composition up top. I plugged the x into the g function, and then I plugged that whole thing into the f function. Okay, and you can do the same thing with numbers. Now, let me show you that way on this next one. Again, this is like g of f of negative 3. So it's essentially telling me, hey, plug a negative 3 into the f function. If I plug a negative 3 into this f function, it gives me a 12. So now I have g of 12. But now this is telling me, hey, plug a 12 into the g function, and when I do that, I have 12 minus 5. Right here, if I plug a 12 in, I get 12 minus 5, which is 7. And it's it. Okay? And right away, if you look at the g of f of x function, this guy right here, you could plug that negative 3 in there, and you're going to get the same thing. Okay? So just keep that in mind. If we do a couple more examples just to practice this thing, again, right here, this is like f of g of x. So if I plug an x into the g function, it leaves me with an x plus 2. And now if I plug that x plus 2 into the f function, and I always write it this way in terms of parentheses. Now keep in mind that this is like an x squared. That's what a variable is, really. A variable is a blank space. It's a space that I'm waiting to plug something into. So x squared minus x plus 1 is like blank squared minus blank plus 1. And what am I supposed to fill in that blank this time? Well, it's right here. It's this x plus 2. So replace I had an x, I replace it with an x plus 2. I'm substituting it in. And now I just have to simplify. X plus 2 squared is like x plus 2 times x plus 2, which gives me an x squared plus 4x plus 4. Here I have to distribute this negative that's right here. So that gives me a minus x minus 2. And now I combine all the like terms. That gives me an x squared plus 3x, and looks like a plus 3. That's it. So that's my composition. I do the same thing going the other way. This is like g of f of x. Again, if I plug an x into the f function, it gives me an x squared minus x plus 1. But now I'm going to take that and plug it into the g function. So instead of x plus 2, I have x squared minus x plus 1 plus 2. Okay, whatever's in those parentheses, that's what I plug in for x. And then I combine like terms, x squared minus x plus 3. Okay? If I do the same thing with numbers, again, there's two ways you can do this. Because I already have the f of g of x, I could just plug that 1 into this guy right here. But let's approach it the other way, just in case I made a mistake up there. I won't make the same mistake twice. So here I go. I'd say f of g of 1. Well, that's telling me to plug a 1 into the g function. So if I come up here and plug a 1 into the g function, it's going to give me a 3. And now I have f of 3, which is telling me to plug a 3 into the f function, which gives me a 7. And that's it. If I look at the next one, it's telling me to do g of f of negative 2. So it's telling me to start inside and saying plug a negative 2 into the f function. So I go over to my f function, and I'm going to plug a negative 2 in. And that might be a little bit difficult to do in your head. That's going to give me a 4 minus a negative 2 plus 1. That's like adding the opposite. So that gives me a 7. So what I have here is g of 7. So now it's telling me to plug a 7 into the g function. And when I come up here and plug a 7 into this g function, it gives me a 9. Okay? So again, the composition is essentially just substitution twice. All right, we're plugging one function into another function as many times as required, or plugging one number into a function and then plugging that into another function. It's substitution inside of substitution on top of substitution. Okay?